Mr. Rokamp's in the audience, and others are as well that worked on this together with us. And so I think we ended up with a pretty good product. And so I have a few documents I will step through that are PDF documents. I'll spend the majority of my time in the PowerPoint just to give some background, and then I'll step through the guidance document and sort of show how that's laid out and how it's intended to be used. And then we'll finish up with a quick run through the appendices, which have all the approach panel guidance information from 1945 to 2016. So without further ado, let's get over here on the screen and give you an idea of what we're going to chat about today. So we'll start with a little bit of an introduction to the project. We'll talk about why new standard plans should and were developed and the rationale behind that. We'll step back and go to a little bit higher level, a little coarser look, and just talk about some of the functions we expect these pieces of concrete to perform. Talk briefly about how the new standards were developed and, the broad consensus Paul and Braden worked with to get us to the standards as they are today. Then we'll step through the standard plans. There's 19 new sheets. They are clumped into 3 different categories. There's a set for bridges without any skew, a set for bridges with small skews, less than 15 degrees, and a separate set of plans for bridges with skews over 15 degrees. We'll talk about the guidance document and why it makes sense to have that developed, what's in it. And we'll spend a good chunk of time talking about design example 1, which is, a 0-degree skew example that's included in the guidance document. And we'll show just how simple it is to put plans together for a project with the new standards. So first, a little bit of nomenclature. So when we're talking about approach panels, other parts around the country might call them approach slabs or other things. But what we're talking about here is the chunk of concrete between the roadway pavement and the bridge itself. So what's in the orange color and the golden color is what we would consider the approach panel. Looking down in a plan view, our bridge again is shown in the blue. This is showing a bridge with significant skew, and so it's beyond that 15-degree threshold. So we have what's called a square-up panel or an extra panel to meet the roadway surface at a reasonable orientation. And so the pink and blue on the left and right show the roadway and shoulders. And the blue in the middle is the bridge, and we'll focus on the gold elements in between the two. So why develop new standard plans? The last major update was in 2016, and they have been updated to accommodate increased demand for traffic barriers and other things. In some ways, they've changed quite a bit. In some ways, they don't look all that different from 1945. The 2016 standard plans were at a point where you were crossing things out, you were boxing things, you were striking content language, and so it often required quite a bit of tailoring to get the sheets included into a set of plans. So if we step back a little bit and ask ourselves what we're really asking this chunk of concrete to do on both ends of the bridge, we want it to carry vehicular traffic from the pavement section to the bridge itself. We'd like to minimize that bump at the end of the bridge. We need to carry drainage off the bridge and take it to a roadway drainage feature or structure. We need to accommodate the thermal movements between the bridge and the pavement. We need to anchor and structurally support the barriers and parapets that are on the approach panel. And we have to have some sort of interface between the roadway section and the bridge section for medians and sidewalks and other elements. So let's step through these one at a time. For carrying vehicular traffic, if we've got an integral abutment bridge, that abutment's going to move horizontally back and forth with temperature changes, and that might create a small void on the back side of the abutment. And so the reinforcing steel in the approach panels is sufficient to bridge that small void on the back side of the abutment. There is no need to do a custom design. You don't need to get out your mechanics books and do a reinforced concrete design. It is basically given to you, the reinforcing steel to be used in the cross section. Another thing we're trying to do is keep the roadway profile in a good condition for traveling public going over the bridge. And so our abutments are often founded, most often founded on piling, which doesn't move up and down vertically. But our roadway pavement may consolidate a bit after the initial construction, and depending on what's below it, it may move up and down with seasonal temperature changes as well. And we're trying to minimize the bump at the end of the bridge. We're also trying to take the drainage that falls onto the bridge and convey it off the bridge, over the approach panel, and out to a roadway drainage feature or a drainage system where it can be properly cared for. We're going to get a little more nuanced here, and so our bridges expand and contract with temperature changes. And oftentimes it's roughly an inch per 100 feet per temperature range we need to worry about with bridges. And so it gets a little tricky with how the bridge abutments are configured on how that movement gets considered, but the roadway designers should not need to worry about it too much. I've got a little bit of content in here to give you philosophically an idea of what the bridge engineers are looking at when they tell you the type of sill to be used at each end of the bridge. And so let's talk about that a little bit more. There are three primary types of abutments used on MnDOT bridges. The default is an integral abutment bridge, which you see in the bottom image on the left. And there isn't a joint between the pavement and the abutment at the top of the abutment. It is assumed to be tied together. And that one row of piling is assumed to flex back and forth with the temperature changes. And it's assumed to be a relatively flexible system horizontally. In the middle, you see what used to be the older standard and gets used quite a bit for larger bridges, parapet abutments. And they can be short or tall, but you can see they're founded on 2 rows of piling or more. And those abutments are intended to be fixed or assumed to be fixed in space. And so as the bridge warms and cools, that little red joint accommodates the movement of the bridge superstructure. On the right is what's called a semi-integral abutment, and it has 2 types: a fixed, which is very similar to the parapet in the middle, and then there's an expansion type that is closer to an integral abutment and how it moves with the structure. And so if we look at each of these types and how they're anticipated to be moving by a bridge engineer, if we've got a 1-span integral abutment bridge, we'd likely assume that the point of fixity was in the middle of the bridge. And those sill joints, what's often been E8 joints in the past on the bridges, assumed to carry and accommodate all that horizontal movement that the bridge generates as it grows and shrinks with temperature changes. Again, if we look at a parapet abutment configuration, things are a little bit different. Our abutments are assumed to be locked in place, and our bridge is expanding and contracting, but that's all being accommodated at the abutment itself. And so our sill joints or the roadway end of the approach panel only needs to accommodate the temperature change movements associated with the approach panel itself. Here's the tricky one, the semi-integral abutment. On the left end, it looks similar to what the parapet abutment had because we've just got movements for the approach panel to worry about at our sill joint. But because it's tied together all the way to the sill joint on the other side, we have a much longer thermal movement on that end. And so it would not be unusual to have two different sill joints presented in a plan set for a bridge that's got semi-integral abutments. And since we're focused a little more on the roadway designers with this presentation, I just wanted to note that for bituminous roadway pavement adjoining the approach panel, that joint that sits on the sill, or the lack of a joint, if you will, has been designed to accommodate no bituminous pavement movement towards the bridge. And so if you anticipate significant movement, you probably need to revisit the recommendations that are in the guidance document. Similarly, if you have concrete pavement coming up to your approach panel, we have considered a 1/2 inch of concrete roadway pavement movement towards the joint. And so when we talk about the types of joints that sit on top of the sills, you'll see that the demand is larger for the concrete pavement than it is for the bituminous pavement. We'll talk about that later. And so here's a table that the bridge designer will provide to the roadway. Well, the information in here will be used by the bridge designer to provide geometric information for the roadway guys for the layout sheet. And so this is intended to show you what's behind the curtain, if you will, for the different sill types. And we'll talk about those in a minute, what A, B, and C mean. But depending on your roadway pavement and the type of abutment you may have a smaller or a bigger demand for movement at the end of your approach panel. And so this table is in the guidance document along with some narrative talking about how to use it. When we talk about joints, we talk about E8 or E5 joints being placed on top of the sill for types A and B. And an E8 joint is 4 inches wide, an E5 joint is 2.5 inches wide. So another demand for our approach panel concrete elements is to anchor the end blocks for our railing. And so here you see an example of an end block receiving the guardrail element on an approach panel. And here's another example. This is actually from design example 2, which shows a sidewalk on one side of the bridge coming off to the roadway section. I believe this is the south side here with the bituminous pavement and bituminous sidewalk. So Paul and Braden organized and had good input from a large interdisciplinary group when the new standard plans were assembled. It included district personnel in construction and design, maintenance, foundations, the concrete units, the bridge office, and consultants. In general, the layouts are larger and simpler to read. The bill of reinforcement for low skew bridges and zero skew bridges is simplified. A complete bill of reinforcement will need to be provided by the bridge designer for larger skew bridges. And we've got 3 fully detailed examples, including pay items and quantities, in the guidance document. The new standard plans were signed April 16th, and they were published on MnDOT's website April 30th, 2024. So they still have their new car smell, if you will. And so they run from 297.223 all the way up to the 228 series of drawings. So what can I tell you about these guys? The numbers do not align identically with the previous standard numbers. 222 was archived and is not included in this set, so you should start from scratch and not try to commingle the 2 sets of drawings. There are 19 sheets here. In a typical plan set, only 8 to 10 sheets will be used. And so off on the right, you can see 3 different columns. A minty green one shows the anticipated sheets you would include for a zero skew bridge. In the blue column, you'd see what you would include for a small skew bridge. And then the far right gold column has what would be included for a bridge with larger skews. So the roadway designer is responsible for assembling the plan set. There are a couple options on how the bid document should be assembled. The approach panels could be integrated with the other standard plans. That's been done a lot for in-house designs. During the development of the plans, there was some feedback that it would be nice to have a package that people could pull out of the plan set that was just the approach panels. And so it is perfectly acceptable to have your approach panel sheets as a standalone set labeled from AP1 through APX. The roadway designer will certify the layout sheet. If you've got a larger skew bridge, the bridge designer will certify the sheet with updated reinforcement information. And in lots of cases, no other sheets will need to be certified. They simply need to be properly incorporated into the plan set. So the first set of sheets are the 223 sheets, the layout sheets, and they are increased in size. The plan views are, and we've got a transverse section and a few tables on there, and I'll talk about that in general in more depth in a little bit here. For those of you trying to figure out left hand and right hand, I guess the way I think about it is if you are standing at the start of the bridge and looking up station, it would be the arm you swing back to point at an abutment. And so if you are standing here and you're looking to the right, hopefully you can see my mouse here, the arm you would swing back to point to the abutment would be your left one. So this is a 15-degree or more left orientation of the skew angle. Likewise, if you swing your right arm back to point to the abutment, you would have a right hand skew orientation. So as mentioned, the plan view was enlarged, the transverse section was added, and there are 3 tables that are new to these standards. And they talk about the expansion joint type, how big a joint needs to be accommodated at the end, what type of detail is provided at the end, and then what type of abutments are used on each end of the bridge. And we'll talk about that more as well. So here's a blow up of the 3 tables that will now be included on that first layout sheet in the package. And this is information that the bridge designer will provide to the roadway designer. The top table lets them know how big a joint should be provided at each end of the bridge. And so you'd come in and you'd label it west abutment, east abutment, and then you just put check marks in the E8, E5, or none box to identify what's going on. You'd identify what kind of sill details being used, and then what kind of abutment. We'll talk about that a little bit more as well. So we talked a little bit earlier about types of abutment, and then on top of that, there's a subdivision for the parapet abutments, whether it has a Davidson detail or an end block detail. And this image here tries to illustrate the difference. For a Davidson detail, the approach panel goes inside the end of the abutment here and all the way up to the joint that has the strip seal gland in it typically. If you have an end block option, in this case, the end block is referring to this chunk of concrete left of the approach panel that sits on top of the abutment. And so things to note are that the tie bars have been changed from a horizontal leg to a curved bar here to allow equipment to get closer to the back wall to compact things. But subtle difference, but if you're computing quantities and lengths, this is the difference between a Davidson abutment and an end block configuration for a parapet abutment. Used to be you needed a square up panel when you had a 10-degree skew or higher. That's been altered in the new standards to a 15-degree limit before you need to add the square up panel. When we talk about the square up panel, it is sort of the peach-shaped part of the approach panel that you see in this image. And the minimum length for our approach panel is 20 feet along the roadway. As the skew angles continue to increase, the actual normal distance of the approach panel shrinks. And so in no case can this dimension be less than 15. So if you have a high skew bridge, you may end up with some geometry that looks a little bit more than 20 feet here along the gutter line. Braden and Paul have added a lot of isometric details to the standard plans to help visualize what's going on at different transitions. They've got it for both the parapet and the single slope barriers. And if you look at the top left here, you can see there are a lot of bevels going on and transitions vertically and horizontally. And so I think the isometrics really help out in communicating what's going on at different points on the approach panel. So with respect to the layout sheet, the roadway designer just needs to select the appropriate layout sheet. Do I have no skew? Do I have a skew less than 15? And then do I have a left or a right orientation to my skew? And then I need to include transition details, which are included on 6 of 6. So regardless of your skew angle, you need to include sheet 6 of 6. So some of this information comes from the bridge side of the world, and some of it comes from the roadway side of the world. And what we've done in the manual is to highlight or cloud information that should be provided by the roadway designer. And that's shaded or illustrated in a blue cloud on these sheets. Information that should be provided by the bridge designer is in the green clouded bubbles inside the guidance document. So a relatively recent item that is been developed for this new design process is a approach panel layout memo. And this is a vehicle for the bridge designer to communicate to the roadway designer what the types of joint, the types of sills, and the types of abutment on the bridge. But it's also intended to give information on stationing for the end of the parapets, and also talk about coordination of pay items, because we've got pay items on top and below, and this memo is a way to coordinate those pay items so they get accounted for properly. So this is the second set of sheets. 1 through 3 are the reinforcing sheets for the small skew bridges. And so it's relatively simple. There are formulas provided for the fabricator, the contractor's rebar fabricator, to use to provide a bill of reinforcement for the approach panel. So a roadway designer would not need to worry about reinforcing lengths and things of that nature for small skew bridges. It's basically taken care of. As mentioned, the longitudinal bars have been increased in size from number 6 bars to number 7 bars to provide a little more robust approach panel. I already mentioned that the tie bars that sort of keep the approach panel from walking off the abutment have been changed as part of the recent details, and so the hooked bars are shown here. And if we get to a situation where the skew is over 15 degrees, the square up panel needs to be provided, and the bridge engineer needs to produce this sheet to be wrapped into the plan set, because it will require a custom reinforcing table to be generated. And so this will require either sheet 4 or 5 to be used, depending if you have a left-hand or a right-hand skew. And then sheet 6 will be common to both types of large skew approach panels. The bottom longitudinal bars were increased from number 6 bars to number 8 to make them more robust. This is a sheet the bridge designer will need to certify. And the bridge designer and the roadway designers need to determine an appropriate submittal date for this sheet to get to the roadway designers for their package. And it might be something like the 90% roadway submittal is when it should be turned in to the roadway group. Sheet 6 has additional details for that makeup panel. New details were added to show the reinforcement. If you have a wide approach panel such that you need to lap bars, you can show the lapped bars on the prior sheet. You don't need to update this sheet just to show lapped bars. As a consequence, this one should not need certification. So you simply go in, you find your skew angle 0 or less than 15 left, less than 15 right, or more than 15, and then you have your sheets to get included into the plan set. There have been some updates to the sill details, and when we're talking about the sills, we're talking about that wedge or rectangle of concrete that supports the approach panel from the bridge side, and then either is cast in with the concrete pavement on the roadway side, or there's a header element, or for option C, there is no concrete element below. One of the things that should be highlighted is that the situations for A and B where there is a concrete element below, that element is held short of the end of the approach panel to provide a space for the drainage elements that are in the joints to drop down and get connected to other elements. So be aware that there's this 12-inch setback for the concrete sill. If we look at sill option A a little closer, we can see some more of the details. And so we've got the concrete approach panel coming in on the left. It's got a little bevel. It's got some bond breaker here to make sure it can slide relative to the sill. And we've got some hook bars that need to be engaged with the roadway pavement. We've got a 2-inch diameter pipe that sits in the bottom of a joint. This used to be a 4-inch pipe and it's been reduced. Then we've got our E5 or E8 material sitting on top of it. Again, for the sills, the reinforcement is simplified. There are equations for it, so the contractor should be able to quickly produce the bill of reinforcement for the project. And so this is for concrete roadway pavements. If we have a bituminous roadway pavement, we will add a concrete header to be the receiving side of the E5 or E8 joint that sits on top of the sill as well. We still have a pipe here, got a pipe here. We've got similar reinforcement details. And for cases where we have bituminous pavement and relatively small movement demands, sill option C is something that can be used. This does not have a sill beneath it. It simply has a drainage pipe cast underneath it. So no concrete sill, no expansion joint. If you have sill option C, you do not have an E5 or an E8 pay item either. There are cases where you may have bituminous shoulders and a concrete main line, and it may be such that you could get away with a smaller E joint on the shoulders than you would on the main line because of that extra demand from the concrete pavement. Resist the urge to put two different kinds of E joints in there. Use an E8 or an E5 joint all the way across the joint. So simply include the 225 sheets if you've got sill option A or B being included in your plans. Certification is not needed, and which ones you have, A or B, are provided on that front layout sheet. So again, Paul and Braden have put together some nice isometric drawings to show people what's going on at the joint. And so we've got situations where we have curb on both sides of the joint. We've got single slope barrier. We've got parapets. So this gives you an idea of what the sill should look like at those locations. There are times where one side of the joint has barrier and the other has curb for either parapet or single slope. And so those details are provided as well in the 226 series. The drainage details have been improved as well. And so one of the things to keep in mind is we're trying to keep that water from the bridge to go off the approach panel into the appropriate roadway element. And so there needs to be turned up elements in these E5 or E8 joints. Otherwise, the water will simply come to the gutter line and wash straight through. So there should be a turn up element here. There's some space here for the drainage pipe to come down. There are cover plates on the outside, but no longer needed on the front face at the curb. If you've got a type C detail at the end of your approach panel. You've got no E-joint. There's no need to include this sheet in your plan set. So the design process is pretty simple. 226 gets included. Only include the sheet, other sheets that apply to your project. Certification's not needed unless you modify things. And that layout sheet up front tells you what to include based on the details. We're almost to the end here. We're to the 227s. This standard joint layout sheet gets used for the small skew or zero skew bridges. It's a little bit simpler than the following sheet for the larger skew bridges. This is to help with L and C joints that need to be provided in the approach panel itself. And so if you've got a wider bridge, wider than the 2 lanes shown here, you should contact the concrete office to get their guidance on any additional joints that should be provided in the approach panel. So here's the 227 sheet for larger skew bridges. Again, these won't need to be certified unless they're modified, but it is highly recommended that the roadway designer talk to the concrete office about additional joints that may be required on these sheets. As the skew continues to get more severe, these pie-shaped segments on the left get longer, and at some point in time, the concrete office is going to want to add additional joints. And as it gets wider as well, there's a need for more longitudinal joints. So simply select the appropriate sheet for what you've got going on for geometry. Unless you change it, you shouldn't need to certify it, but do check in with the concrete unit for joints with or projects with larger skews. And our last sheet to be included is the drainage layout sheet. And so it basically allows the designer to communicate to the contractor that the pipes that are embedded in the sill need to be connected to a drainage feature in the roadway system or into the catch basin and other storm sewer elements. And so again, the size of that pipe in the E5 and the E8 joints has been reduced from 4 inches to 2 inches. Take just a little moment here just to catch our breath. Why develop a guidance document? There are a lot of people engaged in approach panels. There's the roadway guys, bridge guys, construction guys, the concrete unit. And the guidance document is a vehicle to help communicate expectations and preferences, so people have a pretty good idea of what is expected to be included. And so the guidance document itself is 130 pages long with the design examples in it. It highlights the 5 steps that need to happen to basically put together the standard plans for a project. For an in-house design, they would be, as shown here, step 1 is receive the approach panel layout memo from the bridge designer. It describes the expansion joints, the sill type, and the abutment type being used, and key geometry from the bridge side of the world. Step 2, you pick out the appropriate layout sheet, and you annotate it with the stations and elevations for the key points on the layout sheet. So the information in green would be provided by the bridge designer for this example. The blue information is provided by the roadway designer. And it gets annotated, and that's the biggest chunk of work for the entire process here. So after the layout sheet's complete, you select the appropriate reinforcing sheet. And if it's 15 degrees or less, you simply select the sheet and include it in the package. And so here's the sheet for skews that are, I think we've got the 0 degree skew sheet shown here. And so you simply include that in the package. You step through the roster of your package here. If you've got little skew, the blue column you would look at, no skew, the minty green, larger skew, the gold color, and see if you drop any sheets. For example, if you have type C sills, you don't need sill details underneath because there is no concrete element there. And step 5 is simply annotating the sheets with the state project and trunk highway numbers in the title block. The sheet numbers should be annotated appropriately, whether you do them in the standalone AP1 through APX, or if you wrap them into the larger standard plan set. And almost all the sheets would be annotated by the roadway designer. The one exception would be the heavy skew sheet that might be annotated by the bridge engineer. So once we get into the guidance document, I will step through how to put together the standard plans for this example, which is based on a little bridge in southern Minnesota on Trunk Highway 30. It's an integral abutment bridge with some pre-stressed beams for a superstructure. And so I'll talk about that in more detail once I flip over there, which I will do right now. So if we look at the guidance document itself, it is an 11 by 17 format document. And that was intentional because the standard plans are 11 by 17 sheets, and it is easier to look at things closer to real regular size as opposed to reduced in a document. And then we've also put in notes that are on the back side of the 11 by 17 sheets to help people properly complete a plan set. So inside the document, we've got our list of figures, we've got a list of tables, we've got an introduction, a short approach panel history. We go over that 5-step process again in more detail. Talk a little bit about the end work products and coordinating pay items, things of that nature. We've got a section that talks about MnDOT's preferred practices, that about drainage being conveyed off the approach panel, joint sizes, where the parapet ends. Those items are contained in this section. Then for each of then there's a section on the standard specifications, and that's included so we can see what's included in the pay items and the 2406 pay items and what's not. We step through each of the 19 standard plan sheets, and we talk about how to annotate those properly. We've got a design example for a 0 degree skew bridge, design example for an 8 degree skew bridge, and then a 45 degree skew bridge essentially completes the document. And so there are a lot of figures because we're trying to be graphical in how we present things. So here we have our introduction at the front. We need to learn what MnDOT calls approach panels and the different elements. We've got plan views and section views, trying to do a little more lingo conversation in the document. So we're talking about square up panels and bridge elements. We start talking about abutment types and where movement takes place in different types of abutments. There's a short summary here of the history of approach panels by MnDOT. The appendix document has about 240 pages of approach panel history. So if you've got an older project where you're trying to do a rehab on a bridge with approach panels from the 1960s, there's good information in the appendices to help you understand what's likely included in that chunk of concrete. We start to talk about assembling approach panel plans with the 5-step process. Review the approach panel memo is step 1. So we have a sample of the memo here. We talk a little bit about how the bridge guys would populate the data for that memo and the criteria used for that. We've got a table that shows each of the 19 standard plans. We've got the columns for the different subsets for 0 skew, less than 15 or more than 15. We talk about who typically would certify the sheet. Is it typically required to be certified? Who annotates the title block? Then we've got a little column over here for coordination items. And so it talks about the layout memo coming from the bridge designer to the roadway designer. It talks about modifications to the rebar sheets needing to be done by the bridge designer. And it talks about those high skew bridges, having the roadway designer talk to the concrete unit about the joints, the C joints and the L joints. Step 2 is annotating that layout sheet, either 1 through 5 of 6, depending on what your appropriate layout sheet is. Step 3 is selecting the reinforcement sheet. Step 4 is drop what you don't need. Put your project numbers on it and sheet numbers on it is step 5 to wrap it up. In addition to the plan sheets themselves, you'll need to coordinate pay items because we've got the 2406 items include what's in green here. So if you've got curbs on your approach panel, the concrete pavement itself, and the sill underneath, and the E-joints are the 2406 pay items. If you've got barriers and parapets, wearing courses and cover plates, those would be constructed on the approach panel, but would be paid for and listed and presented in the bridge plans. If you've got guardrail and surcharge and other pavement joints that need to be provided, those need to be provided in the project documents in the roadway side. And so this is intended to help people coordinate where the items are getting paid for associated with approach panels. Here's the section that talks about preferred practices regarding drainage and where the end of the approach panel barrier should be. And it talks a little bit about when customized approach panel plan sheets should be provided. There are some guidance images in here to show you where you can put a joint in transitions, in curb transitions. In order for the MASH requirements to be satisfied, you can't put a joint location anywhere you might want to. And for constructability, it's nice to keep joint locations in uniform sections and not put them in a transition area itself. So there's guidance on where to put your joints, where to have the end of the approach panel. The standard specification anticipated to be in the 2025 spec book is provided. This is the draft that was available in May. This is put in there so a designer knows what's included in the pay items, the 2406 pay items. So then there's the full roster of standard plans is provided in the guidance document. So as mentioned earlier, bridge guys are providing the elements in green and the roadway designers, the blue stuff. And here's what's on the back side of that sheet. So here are the notes for standard plan 297, 223, 1 of 6. We talk about where the approach panel starts, where it ends, and then where the barriers stop and start. And so there is guidance that is specific to this sheet on the back side of it. So the idea is you print out this sheet in the back side of it and you have the guidance right there for how to populate that sheet. Similar information is needed for skews. So here's the sheets for the small skews left. Not a lot of extra information compared to that first one. Here's the small skew right. Here's the bigger skew left. A little more information is provided, but it's mostly geometric information on the roadway side of the world. Here's the right-hand skew. And then here's the common sheet 6 of 6 showing the transitions. And so it talks about who's populating the title block and whether or not it needs certification. So we're done with the layout sheet. The next thing we have are the reinforcing sheets. And so we've got the zero skew information on how that is filled out. We have information on the small skews, how that's filled out. And then we get to the skew the other direction. And then for the larger skews, as mentioned, the bridge designer needs to populate the reinforcing list because this cannot be set up with simple formulas. And so this one is certified by the bridge designer, and it likely makes sense for them to annotate the title block as well. So here's the sister sheet for the other side. And then the common sheet for the square up panel typically does not need to be modified. And so the information pertaining to that sheet and why you likely shouldn't need to modify it is provided here. Then we have the 225 sheets, which give us the information for the different types of end options. So we've got option A here with the concrete on both sides, bituminous pavement here with option B, and then with small movement bituminous option C is provided. So information on how to look at that sheet is provided on the notes page. Here are the isometrics that I mentioned earlier. The top left has the information on the L and C joints. The joint details on top of the sill are provided here on sheet 3 of 3 in the 226 series. And so again, the 12-inch offset is something that we're trying to highlight. There are some notes in the back side of that sheet as well. The joint layout sheets for small skews, layout sheet for large skews. Then we've got the drainage sheet for the connection for the drainage underneath the sill itself. And so some notes there as well. We're most of the way there, guys. What time do we have here? 3:25. All right, I think we're going to make it. So we'll move on to design example 1 is the next content inside the design manual. So we're looking at this little bridge on Trunk Highway 30. We've got bituminous pavement. It's a relatively short bridge, so the movement demands are going to be pretty modest. What we did is we tried to make these as realistic as possible as design examples. So we took the old bridge plans and collected the information from there. And there might be a couple details that aren't up to date with these older details, but don't get hung up on that. Don't go back in time. Use the new details. And so we could get the begin bridge and end bridge stations from the general plan. We can get an elevation view and a transverse section from the plans as well. And then we've got the abutment type shown, and here's that old style tie bar, which is not current. And then the survey profile information is provided in the bridge plans as well. So we can see that we've got a bridge with no skews. So we're looking at the minty column of plan sheets to include in our package. And so those are the ones we're going to look at. We'll get information in the approach panel layout memo from the bridge designer. And we will get information about the west abutment, the east abutment. And so here we have type C sill details with no joints provided. And then we've got integral abutments at both sides. And then we've got station and elevations provided for the key points here. And so we've got an end barrier that terminates before we get to the end of the approach panel. And so that'll dictate what type of joint is over the top of our sill here as well. So getting the information into this sheet is the biggest chunk of work that's needed. There is a lot of information provided on the notes page. For example, one, approach panel sheet 1, it talks about how we populate those different elements. We talk about sill option C not having E-joints, so there is no pay item 503 expansion joints design E. And for the approach panels, we compute the plan area, and we've got the 2406-504 pay item, and 172 square yards is what the answer is for this particular bridge. So we include sheet 6 of 6 so we can see how things transition at the parapet or the barrier. So this one is not altered. It doesn't need to be certified, just needs a state project number and sheet numbers added to it. The reinforcing sheet doesn't need anything added to it. It just needs to be annotated down in the title block. The reinforcing list will be provided by the contractor. If someone wanted to know what that reinforcing list should look like, we've provided how it would be filled out from a bridge designer. And so we talk about how we got the numbers in the different slots. So hopefully you can follow our work and check things if you need to. We're up to the 225 sheets. And so from this sheet, we need to include it because we've got sill option C. But all we need to do is add the project number and the sheet numbers. This gives you some guidance on how we got to sill option C being appropriate. We're now into the 226 series of drawings, and so we have bituminous pavement. We've got curb on each side, and so we've got actually this situation down here, and so this sheet is included for that. But all we need to do is annotate the title block. This sheet is not needed because our barrier does not go all the way up to the end of the approach panel. We do not have this situation. We do not have any of the others, so it's not needed to be included in our plan set. Similarly, we don't need the information in our plan set about the E-joints because we've got sill option C. So we don't need to include that sheet. We do need to include the joint layout sheet for small skews, which is provided here. All we need to do is annotate the title block. And we need to include the drainage sheet to get the pipe under the end of the approach panel connected to a drainage feature, but all we need to do is annotate the title block as well. And that is all that's needed for the design example 1. Inside the guidance document, I won't step through this other than to highlight that we do have the 8-degree skew design example. And we have the 45-degree skew design example as well. So that gives you an idea of what's in the guidance document. The last document is the appendices. And so inside the appendices are 2 main sections. Appendix 1 or A is guidance for bridge people on how to assemble that layout memo, I should be able to say that. And Appendix 2 is basically the row camp information, and it's substantial. So the list of figures will actually grow by another 100 or so when I finish getting the last set of figures incorporated into it. And so there's information here on how to assemble that memo, how to compute the geometry and abutment types. For each of the design examples in the main document, there's an example here of how to put together the memo for that example. And so that information will get conveyed to this sheet. Similarly for design example 2, the same information is assembled to put on this sheet, and it talks about having the sidewalk on the one side and the couple additions needed there. Design example 3 talks about the last design example. And then all the historic documents, and Paul and Braden haven't seen that I've added Paul's summary here as well. So Paul put together a really nice summary of everything he could find from 1945 up to 2016, which is the last of the prior standards sheets. And so some of these old sheets are entertaining from an engineering perspective, I guess, but so once they're on the website, Braden will post them and you'll be able to have them at your fingertips if you've got some old bridge projects in your collection. So I think I've jumped and talked about that. Let's go here, make this bigger. We stepped through design example 1. I stepped through the appendices. I think I'm at the thank you point, Braden.
I think this is the point where we say thank you, Steve. The effort Steve went through to not only do this presentation, but also the guidance document was substantial. So there's a lot of people to thank, and Paul Rokamp and a whole committee that was involved in this, but really, really appreciate your work on this.